Hello, my name is Luis Proctor, and this is my ultrasonic sensor video for Project 4. Now, let me start off by explaining how my circuit works. You have the ultrasonic sensor right there. You have the programmed microcontroller right here that's been programmed using the Arduino software, and it's plugged into my computer, which will eventually read software over there. But let's start off with the ultrasonic sensor. So the ultrasonic sensor has 4 pins, and they're connected respectively, as you can see there on the E column. First off, it's grounded using this yellow cable. Secondly, the echo is connected to this red cable right here that is connected to this pin right here. And then the emitter is connected to this blue cable right here that is connected to this pin right here. Let me zoom in so that you can get a closer look at that. And then, of course, power supply. Now, how does the ultrasonic sensor work? Well, the emitter shoots a sound wave that when hits an object, it'll bounce back. So it'll travel, bounce back from the object, and then come back here to the receiver, which will then receive and come back to the microcontroller. And then, given the information, the microcontroller will then decide what inputs or exactly what outputs to send, given the programming, of course. So in this example, let me just place my hand here as the object, and you can see how it's working. You have the power supply that's obviously connecting everything, completing the circuit. And you have the ultrasonic sensor shooting a sound wave, bouncing back, hitting the receiver. Receiver travels through the pin, and then the pin gives information to the microcontroller, which then decides what output, according to the program, to send. And I'm pretty sure I covered everything there. I have 3 LEDs here, depending on the distance. And then there's the buzzer, of course. These 2 are representing that it's in fact completing the circuit. This right here is the ground right here, and this is the power supply. And I accidentally triggered this thing somehow. Let me see if I can adjust it. I can't. But yeah, I think I covered everything for my circuit there. Let's move on. I'll show how it works later on. Let me explain my code over here, because I did make a few changes, not many. But of course, I already explained that we had to define the pins that correlate to the ultrasonic sensor and the LEDs, and that's what they are. So 11 for the trigger pin from the ultrasonic sensor that sends the sound wave, and the echo pin 12, which receives the sound wave and then relays it back to the microcontroller. And then the LEDs connected to those pins, 7 being green because it's the one that, well, I'll explain later, that can detect the longest distance and turn on, and so on and so forth. So LED 2 is going to be blue, and then LED 3 is going to be red. And then the buzzer, that's for when an object is within very close proximity to the ultrasonic sensor. But anyway, moving forward. In the void setup, that's where we define these things. We have to define what's an output and what's an input. And what I mean by that is that the microcontroller sends or receives signals, but we have to tell which is which. And here, we define the trigger pin from the ultrasonic sensor to be an output. So we make the microcontroller send a signal to the ultrasonic sensor to send an output, which is the sound. What comes back onto the echo pin is an input, which goes back into the microcontroller. And then, given the code, it's sent back as an output to the other LEDs, depending on the parameters it's met, or the active buzzer, of course. And then that's the void setup. Now for the void loop, this is where we define the three variables: duration, distance, and distance in inches. So for digital write, we have the trigger pin. It starts off at a low setting. I mean, not at a low setting, it's off. So when this code runs, it's off for two microseconds, and then it turns on for 10 microseconds, where the trigger pin sends the sound wave, and then it turns off again. Now the duration is calculated by the pulse in, which is the echo pin, which turns on, and that's how long it takes for the, well, as a professor described it, as flight of time of sound. And I'm guessing an easier, or maybe just as easy way to say that is that it's how long it took for the sound signal to travel, bounce, reflect off of the object, and then come back. So displacement of sound wave within the what duration means is how long it takes for the sound to shoot from the ultrasonic sensor, hit the object, and then come back. So displacement, I guess, in this situation is the duration. But the distance is not displacement, so you have to calculate for that. And we did have to adjust 340 meters per second so that we could get the units in centimeters, and that's why it's been adjusted to 0.034. Now the calculation for determining distance is simple enough. It's duration divided by 2 times 0.034, and the duration is already explained as being how long it took for that process to happen. And then the distance is in inches is just the distance times the I can't remember the word for, but for the for the conversion, I'm sorry, for the conversion between centimeters and inches. And that's simple enough algebra or multiplication right there. And then after it's done all this, it continues on, and the distance is this right here. So what's calculated using this formula right here is what's gonna I guess enact or execute within the code. So let's say that the distance is less than or equal to 30. Well, the first LED is going to turn on. Else it's gonna turn off. So that just gives it one or two options. If it's less than 30, I'm gonna try to calculate it there. Yeah, LED 1. I don't know why it keeps turning off, but LED 1 turns on. That's less than 30 inches right there. Centimeters, I'm sorry. Now over here, it turns off. That means if or else. If, else. And that is the same with the following for LED 2, for LED 3, and then for the buzzer. And then it gets a little interesting over here, but I'll get to that in a moment. Let me demonstrate these again. So that's LED 3, stop turning off. Let's see here. Okay, right there. So that, oh, actually, let me show you using the serial monitor. Oh, I already have it open. Okay. So there you go. That stopped turning off. And there you go. It's at about an average of 25 centimeters, and it turns off. It can be a little inconsistent at times, but it works for the most part. There you go. And then you move it closer. That's the two LEDs, and of course that's below 20 centimeters as it is set in the code. I'll go back to it right now so you can see it, and then move it a little more. There you go. And that's below 10 centimeters, so LED 3 turns on. yeah, there, it's looking really good. And then once it gets too close, it emits that buzzing sound. And there you can see it emitted the buzz when it was below 5 centimeters, and it was like that for about 3 seconds at around an average of 4 centimeters. And now that it's not detecting anything, it says out of range. Now let me go back to my code. Actually, let me just move this out of the way. But yeah, that's how it is. So the LEDs don't turn off when another one turns on, and that's just because the code is designed that way. As long as it's below 30 LED, the green LED will always turn on. But there are real world applications where this wouldn't be practical, although it is practical for some real world scenarios. So it's good to understand the various implications of a system like this. But yeah, that's how it's defined. 30, 20, 10, 5. So it gets interesting around this part of the code, because even though there's no light that it'll affect, it will still display out here the distance. So let me show how that works. Let me first explain the code. So if it's at a distance greater than 50, it'll show out of range, and of course there it's showing out of range when I'm not intruding in its space. But if it's else, it will still display distance and everything and so on, but it won't turn on an LED because there's nothing to coincide with it. But let me show what that looks like. So let's demonstrate if first, and let me just play with the distance over here. Nothing, of course. Let me get closer, but not close to where it'll turn on the LED. And there you go. That's the else statement. It's still displaying distance in centimeters and inches, but since there's nothing in the code to tell it to turn on any of the LEDs, it won't do that. But yeah, it's pretty cool. And then of course at the end you have the delay in a unit of 1000 for how long it does it, and then it comes back and then it loops and it does the thing over again. The delay of 1000 is how often each of these refresh. But yeah, that's essentially my project right there. I'm pretty sure I covered everything. I covered the ultrasonic sensor pins, its correlation with the microcontroller, and the outputs from the programming onto the pins, given distance of the object. And I showed the serial monitor, and I showed everything from the code here. And yeah, that's my project. Thank you.